This is a sum on similarity. In triangle ABC, AP is to PB is 2 is to 3. PO is parallel to BC and is extended to Q so that CQ is parallel to BA. Find the ratio of area of triangle APO to area of triangle ABC and also the ratio of area of triangle APO to area of triangle CQO. So I'll just copy paste this figure. Now AP is to PB is 2 is to 3. So if AP is 2x, PB would be 3x. So AP by AB, because the first question needs the area of triangle APO to area of triangle ABC. So AP is to AB is 2x by 5x, which is equal to 2 is to 5. Why 5x? Because it is 2x plus 3x. So AP is to AB is 2 by 2 plus 3, which is 2 is to 5. So we are doing this for the first question. So the area of triangle APO to ABC. Now these two triangles are similar. I'll just put a tick mark. This triangle is similar to the bigger triangle ABC. So which means triangle APO is similar to triangle ABC. By which similarity? It is the AA similarity. Why two angles are same? Because if you notice in this triangle APO and triangle ABC, so I'll just draw the triangles separately. So the smaller triangle is APO, while the bigger triangle is ABC. So this A, P, O, and this A, B, C. So I just drawn these two triangles separately. So if you notice in these two triangles, angle A is the common angle and angle P, which is angle APO, will be equal to angle ABC. Why is that? Because PO is parallel to BC. So these two angles, APO, where I'm drawing it in the main figure, and angle ABC are the corresponding angles where the transversal is AB and the parallel lines are PO and BC. So these are corresponding angles. And similarly, AOP is also equal to ACB because of the same reason that PO and BC are parallel lines and AC is the transversal, and these two angles AOP and ACB are corresponding angles. So these two triangles APO and ABC are similar. So this is the symbol for similarity. This is a wave symbol by AA similarity. And when two triangles are similar, the ratio of areas would be equal to the square of the ratio of the sides. Hence, ratio of areas is equal to square of ratio of sides. Ratio of areas of these two triangles. So the area of triangle APO is to area of triangle ABC. Area APO is to area ABC is equal to the ratio of any two corresponding sides. Let's say it's AP is to AB, square of that. So I'm talking about these two sides, AP and AB. So I'll just mark it in red to be more clear. So AP and AB. So the ratio of these two sides, because these two triangles are similar, so the ratio of these two sides, if we take, which is 2:5, I'll just mark this in pen. So AP is to AB is 2:5. The square of this ratio would be the ratio of these two areas. So would be equal to the square of 2 is 4 and the square of 5 is 25. 4:25. So this is the first answer. I'll just block this in green. So this is the answer for the first question, which is the area of triangle APO to area of triangle ABC. Now let's go to the second question. So the first answer is 4:25. So the second one is APO versus CQO. So we are talking about these two. So now I'll again copy paste this figure down. APO versus CQO. So I'll just put a tick mark. APO versus CQO. Now these two triangles are also similar. Why is that? Because these two angles are vertically opposite angles of two intersecting lines, so which are always equal. So AOP is equal to COQ because they are vertically opposite angles. Similarly, like earlier, these two lines are parallel. AB is parallel to QC. So if these two are parallel lines, AB and QC, this is a transversal AC. So these two angles are same because they are interior opposite angles. Interior alternate angles, I'm sorry. Interior alternate angles. Just to be more clear, if there are two parallel lines, and there is a transversal cutting them, these two angles I'll mark in red. These two angles are called interior alternate angles and they are always equal. So it is the same case in our case. Angle A is equal to angle QCO. So when two angles are similar between two triangles, the the third angle is also similar. Then when the two angles are same between two triangles, the third angle would also be the same, which means this would be equal to this by the same um, explanation, which is they are the interior alternate angles, or even the sum of angles being 180 because two angles are matching up. The third angle has to match up because ultimately they have to add up to 180. So these two triangles are similar. Now let's see if we have the ratio of sides. We know this. We know that AP is to PB is 2 is to 3, and AP is to AB is 2 is to 5, like said earlier. And because APO and ABC are similar triangles, this ratio is also equal to AO is to OC. So just to be clear, I'm writing, since I'll write it in a blue font. Since APO triangle is similar to ABC, AP by AB would be equal to AO by AC. Because these two triangles are similar, so the corresponding sides, the ratio would be the same. AP by AB is equal to AO by AC. That would be equal to 2 is to 5. So if we notice, AO by AC is 2 is to 5. So AO by OC would again be 2 is to 3. This is also called the basic proportionality theorem. So I'll just mark this in red. I'll put a pencil. So this one, AO would be 2 and OC would be 3. This is obtained from the similarity of the first pair of triangles APO and ABC. So AO is 2 and OC is 3. So that's the ratio. But then these two triangles are also similar. The other pair, which we just spoke about, which is APO and COQ. And these two triangles are already prone to be similar, again by AA similarity. So the area ratios would be the square of the ratio of the sides. And if this is 2:3, this one will also be 2:3. PO by OQ would also be 2:3, and AP by QC would also be 2:3, because when two triangles are similar, the ratio of the corresponding sides would be the same for if you pick up any pair of sides of the similar triangles. And then, but then we don't have to really bother about reporting the AP by CQ ratio, because what we have been asked is the ratio of the second question, the ratio of areas of APO by CQO. So the ratio of these areas, I'll write it down. So area of APO is to area of CQO is equal to square of the ratio of the sides, which is AO is to CO, which is equal to square of 2:3, which is equal. I'll just shift this down. So it's the square of 2:3, because AO is 2 and CO is 3, and 2x and 3x. So the ratio is 2:3. So the answer is, I'll just mark this in red again, is equal to 4:9. That's the second answer. And this make the block in green like earlier. This is the second answer. So this was a sum on similarity of triangles. Thank you.